Okay, so the past 18 months, the capstone project that I've been working on, I named Getting to the Starting Line with the goal of predicting NCAA national qualifiers, specifically in the 5K. So to begin, the genesis of my project began whenever I ran for Texas A&M during my undergrad. I ran cross country and long distance on the track and field team. And the goal of every season throughout my undergrad was to qualify for nationals. And so how do I do that? The NCAA splits the country into two regions, the East and the West region. Each region has a regional meet every year, which is comprised of the top 48 performances in each event. Then at the regional meet, the top 12 finishers advance on to the national meet. So as I said, every year the goal was to get to nationals. This was the goal of every single athlete in the NCAA, which leads me to my primary question. Given a runner in a race location, can we predict whether the runner will qualify for the first round of nationals, called regionals? So the overall process that I went through over the past 18 months was to acquire the data. First, I had to scrape the data from a database. I'm sorry, my furry roommate is making a cameo appearance. First, I had to acquire the data from a website called TFers, which is just a data host that has all kinds of data from the NCAA. Then I had to clean the data. There were duplicates and incomplete pieces of data. There were outliers that I had to identify and take out. After cleaning the data, I could visualize it graphically. This was important because I wanted to look at the data from the athlete level, but also from each race. I wanted to look at races that a lot of people qualified for nationals in versus races that didn't have any qualifiers. And was there something different about between the two of them? After I visualized the data, I then transformed it. I took the raw data and saw if I spun it a different way or created new variables, would these new variables provide insightful in my predictive model? Using the raw and the transformed data, I then created and analyzed models. And analyzing my models, I needed to balance the predictability, how accurate was the model, with the usability. I needed to build a model that was simple and I could communicate to coaches in such a way that they would see the value and want to use it on their own athletes. This led me to my conclusions. How could I improve the current model? And can we expand this model to other events such as the 10K? On the right here is a baby python because, like this picture, I myself came into this program as a baby python programmer. And throughout this entire process, I challenged myself to do the entire thing in Python. I point this out because I had zero programming experience coming into the program. But this program and this capstone have enabled me to come a long way. Okay, I won't go into details of the data cleaning process that I went through for the sake of time, but at the bottom is a Python output picture of two data points that were obviously outliers. You can see that for a 5K, the data said that two individuals ran 10.85 minutes for a 5K. If you've ever tried to run a 5K, which is 3.1 miles, you know that 10.85 minutes would be very fast. It is also very unrealistic. So just having the domain knowledge of the data set that I'm working with helped me identify and clean the data. This is an example of the data transformation that I went to. I picked a completely random athlete from the data set who happens to share the same name as me. and captured the 3 indicators of what I thought might be informative to building a predictive model. I wanted to capture at the athlete level their experience, their talent, and their current fitness. So this is, again, a Python output of just various variables that I looked at and considered whenever transforming my raw data into a more usable mind frame. After looking at the athlete, I sought to look at, like I said, the races as separate entities. Of the 1,633 individuals who attained regional qualifiers over the 9-year period worth of data I had, there were only 159 different regional qualifying races. So I wanted to look at what was different about these races. I discovered that the second place runner in a regional qualifying race tends to finish closer behind a first place runner than in a non-regional qualifying race. All of my findings suggested that the regional qualifying races are just overall more competitive, which makes sense because we all know that surrounding ourselves with people who are better than us tends to bring out our very own best. This is an example of the modeling process that I went through. I went through a couple of very complex models to identify a simple solution. It was important that I come up with a simple solution that I could communicate to coaches in the NCAA in such a way that they would not only understand, but be able to use and apply to their own teams each year. On the right here is 2 decision trees I made, one for a men's specific predictive model and one for the women's specific model, which helped identify where I should segment my data, what values was most important for each of my models to build a more simple model off of it. Finally, after building my linear regression model, I needed to evaluate whether I met my business question. Given a runner in a race location, can we predict whether the runner will qualify for the first round of nationals? I evaluated it by building a classification and problem. I created a confusion matrix to identify if the runner qualified for regionals, did I predict that they would qualify for regionals? I defined this by identifying what the regional qualifying time was each year, since it was a little bit different. And it turns out my model came out with a 97% accuracy. So though the model does not pinpoint every single runner to the second of what they would run in each race, it was 97% accurate in identifying whether they would qualify for regionals, which was the goal of the model. So I won't go into details on how a coach may use the model just for the sake of time right now. But if we have Baylor track and field coach Todd Harbour, who has a moderately talented distance program, but only $5,428 per athlete to work with, he wants to know what athletes and what races he needs to invest in to maximize his ROI. Where does he need to take the athletes to get regional qualifiers so that he can qualify as many athletes as possible for nationals? Because after all, this is how he's making his own living. The goal every year for every NCAA athlete and coach is to qualify as many people for nationals as possible. So that's a little snippet of what I've been working on for the past 18 months. So I will now let us go on to the next person. Thank you.
The student that we output in the MS Analytics degree at Texas A&M will be someone that can take data from a variety of sources, put it together, clean it up, build a complicated predictive model, and then turn around and explain it in layman's terms to clients or board members. And this skill right now is hard to find in our job market.